Hey guys, Ivan from Reactive Network here. I'm happy to greet you at our first workshop. Thank you very much for joining us. Your attention is one of the most valuable things for us because, it will be great to have your feedback on our tech and to learn more about your ideas. And today we're gonna have a workshop, and let me share a few things about what we're gonna be discussing today. So this is our Unicorn workshop. It's connected to our Bounty program. I believe you can see the link to the Bounty program in the description of the video, and all the other links as well, such as to our developer chat and other stuff. And so the topics of our today's workshop will be a brief overview of Reactive Network. So I won't be going into much detail, especially much business detail, because that's a topic for another discussion. But I will just briefly share what's important for us today to dive into the tech and to start doing the actual bounties, right? Now, then we're going to discuss some of the potential use cases for reactive smart contracts. And I will show also some schemes as well. And we will discuss more of the use cases in the context of our Reactive Bounty program. And then, and this will be, I believe, the most important and the biggest part of our workshop, we will show you how to deploy your first reactive smart contract so that when you start doing the actual bounty program, or when you start developing some reactive smart contracts out of your own interest for your own purposes, which I really hope for, you will have everything that you need. All right. And in the end, I will share more details about our bounty program. So without further ado, let's go to the overview of Reactive Network through this scheme. So basically what Reactive Network does, it allows you to react to EVM events, to process them with some logic that you describe in Solidity in a reactive smart contract, and then to do some after effects on the same or other EVM chains. So it can be described as an on-chain if this, then that. So with our previous product, which is a data indexing solution, PARSIQ, we had a lot of requests for being able to react to on-chain events with on-chain actions. And that's basically what we're doing here. So let me go over this scheme. So the first thing we have here, the yellow one on Ethereum network, it's an origin smart contract. It's some smart contract that we're interested in monitoring, right? And some event is happening on this origin smart contract. Then Reactive Network sees this event. It's triggered by this event, and it runs the corresponding reactive smart contract, the reactive smart contract that was subscribed to this particular event, defined by its topic 0 in this particular smart contract, right? Then the reactive smart contract, it does its own logic. So it's a full EVM Solidity smart contract. So it has a state, it has Solidity language for you to describe any conditions, to check any conditions, and to describe any processes that you want. And then in the end of it, it's supposed, if all the conditions are met, it's supposed to emit a callback event. And a callback event is a special event in reactive smart contracts, which starts the execution of the transaction on a destination smart contract. And the destination smart contract, it's a smart contract on which you want to run a transaction, right? So it might be some liquidity pool, it might be some voting system, it might be your smart contract wallet, whatever. So you want to do some action there if some other action happens on the origin smart contract. So this is the basic workflow, and this is basically what it does. So it sounds very simple, and it's pretty simple in building on it, because it doesn't add a lot of tech on top of what you already know, because it's Solidity, it's an EVM chain, it's the same set of tools, like you can use MetaMask, you can use Foundry, You can use Remix. You can use whatever you want. And you don't need to learn any new language. You just need to deploy an additional smart contract, which is a reactive smart contract on a reactive network. And it's deployed basically the same way as any other smart contract on any other EVM chain, right? So let's go to the next one. And the next one reiterates on what I've just said. So we have a concept of inversion of control, which helps to understand what's happening here. So in the traditional, the usual EVM workflow on the left, we have an externally owned account address, a user which holds, which is controlled by the user's private keys. So private keys might be controlled by a person or a bot, but anyway, from the Ethereum standpoint, it's an externally owned account, right? And then you sign a transaction with this private key from this account to send Ether or to interact with any smart contract. For instance, to interact with an ERC20 smart contract to send your tokens to someone else. So that's a usual EVM workflow. So Reactive Network implements the inversion of control. And on top of the existing workflow, it gives you a possibility to follow the Reactive Network workflow, which is as follows. We demonstrated on the example of a Uniswap pool. For instance, we are monitoring some swap event, and we want to trigger a transfer on an ERC20 token smart contract based on this event. So in that case, the actual transfer, it's triggered not by a user signing their transaction using their wallet and their private key, but this transfer is triggered by the swap event happening on the Uniswap pool. And that's basically what we call an inversion of control, because it's controlled not by a private key, but by another smart contract, a reactive smart contract, which in turn reacts to the specified origin smart contract. Okay, so to understand better the potential of reactive smart contracts, yeah, I will be saying reactive smart contracts a lot today. Let's take a look at some of the examples of what can be done here, right? So one of the examples is a Uniswap stop order with RSCs. So you might be aware of the Uniswap hooks that they implemented in Uniswap v4, right? And that's a great thing. However, it only applies to v4 and it only applies to building on Uniswap. So you can also do some of the things that can be done there using reactive smart contracts. For instance, stop order. Okay, so I'm not sure, by the way, that this is a correct trading term, but anyway, that's what it is. So we have your account here. So the three blocks that are yellow, they're on Ethereum network in that case, and the one block that is blue, it's on Reactive network. So the top left block is an externally owned account, which interacts with an ERC20 token and approves this token for the reactive smart contract. And then whenever a reactive smart contract sees a sync event on a Uniswap smart contract, and this event signifies the change of the exchange rate. So whenever exchange rate changes on this particular Uniswap pool, there is this sync event. So you can take the exchange rate and calculate it based on this event. So the reactive smart contract does that. And if this exchange rate is more or equal or less or equal, depending on your choice, than the one that you specified in your reactive smart contract, then it emits a callback. And then a callback swaps the tokens for the user. So basically, it takes user's funds, then it swaps it on the Uniswap pool, and then it sends back to the user, all within one transaction as usual for swaps, right? So this is how a stop order can be implemented using Reactive Smart Contracts, and it can be implemented not only in Uniswap v4, but on any pool, and also basically not even on a pool. You might be, for instance, monitoring an exchange rate on an Oracle, and then running the swap on the pool. Okay, so this is a pretty simple one, right? So here I'm illustrating some concept that we will need later today. So let me dive straight to the second thing, which is potential use cases for Reactive Smart Contracts. And also this is the same as yeah, sorry. I'm a bit mixed between the windows here. Okay, so the next thing we're going to talk about is potential use cases for Reactive Smart Contracts. And here, I believe it's better to go to our Bounty program, right? And for me to share the screen. Just give me a few moments to get there. So yeah, as I have said, we are running a Bounty program. And the bounties there, they're not arbitrary. They are
there is one question.
They are some of the things that are actually making sense for the business implementation. But yeah, also I'm told that we have a question here. I don't think, yeah, I can see it here, right? And yeah, so we have a question. And so let me show it on the screen. So the smart contracts need to have the data you need to be able to transfer to someone on the other end. So the ending smart contract doesn't need keys to work. Yeah, that's a good question. I'm not completely sure I understood it correctly, but I will try to answer that. So the ending SC doesn't need keys to work. Yeah, so on the destination smart contract, the destination chain where the transaction is executed. Yeah, let me go to this slide. On the red one on this slide, someone is gonna sign the transaction anyway. It's just not going to be the user with the user's private keys. It's going to be Reactive Network with the Reactive Network private keys. So currently we are working with a partner whose name is going to be disclosed soon. And with their help, we'll be signing the transaction on the destination chain in a decentralized manner. And that's how the transaction is going to be executed. And the first part was, so the smart contracts need to have the data you need to be able to transfer to someone on the other end. Yeah, I believe that was the part of the question. So yeah, thank you for the question. And guys, yeah, I will be monitoring the chat from now on. So whenever you have any questions, you can ask them in the chat, and I will answer them either right away or in the end of the workshop. All right. So yes, now I believe I can share my screen. Share screen. This one. Okay, yeah, sorry for the mirror tunnel. And yeah, so here's the repository with our Bounty program. I believe you can find all the links below. And let's go through this thing here. So I will talk about the judging criteria in the end of the workshop, because currently we're here for the use cases. And let me go through the use cases, because that's what we're going to discuss. So here are the bounties that we offer for the first bounty program. The first one is a cross-chain Oracle. So basically, we have some super short descriptions here. They're deliberately short for you to use your creativity and to come up with your own solutions rather than us describing how we see it. So yeah, they're pretty short. Sorry, that's my cat. Okay. Brunhilda is her name. Okay, so The first one is cross-chain Oracle. So basically, the use case is, sorry. Okay. I'm sorry, guys. The use case is as follows. So let's say we have a chain on which the oracle of interest is not deployed. For instance, you are starting your own chain, for instance, or you're working on an unpopular, a small chain, and you want some data from some trusted, good, well-known oracles that are not deployed there yet. You can do that pretty easily with Reactive Smart Contracts. So you will be monitoring the origin chain for those Oracle events, and then the Reactive Smart Contract will be triggered by those events and will feed them to the destination Oracle Smart Contract on the chain on which you're working, right? That's pretty simple. Another use case for Reactive Smart Contracts is an automated token buyback and burn. So let's say you have some treasury smart contract, which is managing your tokens, your funds. And for instance, whenever some metrics of your token or of your project reach a predefined threshold, or not a predefined, or some moving threshold, you want to burn some tokens to reduce the supply. So you monitor the corresponding events on the chain, and then when the metrics, the conditions are met, you burn the tokens. So that's pretty simple. Another one is cross-chain governance, and the next one is automated governance. So these two are not to be mixed. They're similar but different, and also they can be implemented together. So automated governance is, let's say you have a governance smart contract, you have voting there, and then when the last vote is done, when the voting threshold is reached, you want to execute the decision that you are voting on. So you will need either to run an additional transaction by some person or by some bot that will be monitoring the number of votes and then execute this decision, or you will need to execute this decision on the last vote, which means the person who is voting will be paying for the gas, which is not fair. So using the Reactive Smart Contracts, you can avoid those cons, leaving just the pros. So you will have the automated execution of this voting decision, and you will pay for the gas yourself, not asking the voters to pay for you. But if you working on several chains, you can also do a cross-chain governance. So let's say you have voters on several chains, and you want to be able to synchronize the number of votes over all the chains, right? Then Reactive Smart Contracts will help you. They will synchronize basically the number of votes between all the chains, so that the number of votes is the same everywhere, and so that you will be able to synchronize those votes and accept votes from voters on different chains. And then you can also do an automated governance on top of that, which is when the threshold is met, the voting decision is executed, right? Okay, so the next use case for Reactive Smart Contracts is an automated one-step swap. And this one, I believe, might be the most interesting one because it's the most practical, and a lot of people have the pain of needing to sign 2 transactions when swapping funds on a DEX, right? And especially this pain, I believe, is big for the first-time users. So let's say you're developing a DEX, or you're developing an interface, an aggregator, whatever, and you want to reduce the pain for the newcomers. You can do it using Reactive Smart Contracts. I won't spoil how exactly to do that because that's a part of the bounty. But we will tell about that in our upcoming articles after the bounty program is done. So you will hear about that more. Another thing we can do is automated insurance payouts. So let's say there is a smart contract that is paying out clients in case of the insurance event, right? So then when this event happens, a Reactive Smart Contract can trigger the payout automatically. because this event might happen not on the insurance smart contract, but on some Oracle, some external smart contract, and so on. A similar thing is in IoT payouts, only the payout is not connected to an insurance event. It's connected to some IoT event. It might be some goods being delivered or something else. So basically, those two use cases, they're pretty simple technically on the reactive smart contract side of the thing, but they might be more complicated in business terms, right? Yeah, the next one is automated prediction market, which is pretty self-explanatory. So we have prediction markets, and we want the payouts and the other stuff to happen automatically when the event happens. It might happen also on the external Oracle or something else. And also there's automated funds distribution. So let's say you have some staking in several places, and then you want to collect it all in one place, and then you want to distribute it between the stakeholders of your, let's say, treasury or something. So using reactive smart contracts, you can do it automatically. All right, and that's it for this part. Let's go to the next one, which is how to deploy your first reactive smart contract. Yeah, a bit of water. All right. So I won't be showing all the links because I believe you can find them below the video on our website, on our Bounty program site. We did our best to make sure that it's all reachable. And the next thing I'm going to show, it's our reactive smart contracts. Just give me another moment to get to this page. Okay. Okay. So here we have a repository with our reactive smart contract demos. And this is the one I'll be working with today. So you can see all the instructions here. Also, you can see all the instructions in our education page. By the way, let me show you how to see all those things. So this is our website. You can go to the docs. There's a welcome thing here. We have technical docs, which are basically like more brief description of more deep technical things. And also we have an educational course right here. So if you're stuck, whenever you're stuck doing bounties, you can take a look here. We have a lot of explanations and stuff here. And also we have a good getting started page here, which shows like how to deploy your first reactive smart contract, where to get Copley testnet to actually deploy it, tells about reactive architecture in case you're interested. Also, there is a link to demos, to education, and to all the stuff. So it's all reachable. And right now we're going to be talking about the first of our demos, which is a basic demo. And now I'm going to switch to my Visual Studio here, because that's where I got all this stuff, right? Okay, so first of all, to get your to deploy your reactive smart contract, you'll obviously need your React tokens that you will use the same way Ether is used on Ethereum network to deploy smart contracts, to run the transactions, basically gas, right? So it's described here on Getting Started page. Let's follow this link. So basically it says that you need to send some funds on Sepolia to this address, and you will get some funds on Reactive Network. Okay, so right now I'm on Reactive Network. You can add it to your MetaMask with all this information. RPC URL, chain ID, all the other stuff, the same way you add all the other chains, right? So currently I have one Copley React here, right? And let's switch to Sepolia. And let's send some funds to this address. Send this one. We don't need to send a lot. Let it be 0.1 Sepolia Ether. And let's send a transaction. Yeah, so that's the first thing we need to do. After that, this transaction is confirmed. And after that, soon we will get some React on Reactive Network, right? So that part is done. The next step would be for us to understand the code that we have here. And before we understand the code, let me walk you through the repository. So in our basic setup, we work with Foundry to deploy the smart contracts. We have all the instructions for Foundry. You don't really need to know a lot about Foundry, because basically we just install it, and then we have all the instructions in our READMEs, so you don't need any initial knowledge to use it. You just need to install it, and how to install it, it is described in our repository, the same repository that we saw here, right? So yeah, it has a demo in its root, and this is the demo in its root. It explains how to install everything, and also it explains that we need some of the predefined environment variables for everything to run, because we will be using them in our deploying scripts, right? So the first thing we need is Sepolia RPC to deploy smart contracts on Sepolia network, because yeah, as you remember from the scheme, we have the origin smart contract, the reactive smart contract, and the destination smart contract. And yeah, we will need to deploy a reactive smart contract and some of the smart contracts on Sepolia too. So we will need Sepolia RPC, a Sepolia private key for your account, right? The reactive RPC, which you can find in the docs, the reactive private key, which might be the same or different as your Sepolia private key. And also, like, if you're working with this setup, you will need to save your private keys as environment variables, but also you can try working with Remix, and we will soon have an article on how to deploy reactive smart contracts using Remix. And in that case, your private keys, they will be managed by MetaMask or another wallet, right? Okay, so you will also need the deployer address. So the address of the your address that you are using for deployment of those smart contracts, basically the same for which one you have your reactive private key. Then you will need to specify the system smart contract address, and you can find it also here on this page here. You can always find the actual info, right? And then also you will need a callback sender address, which will be different for every use case. So let's go straight to demos, and we have some structure here. So we have SRC, demos, and then demos, right? And today we're interested in a basic demo. So let's take a look at its README here. So for every demo, you have README on how to run this particular demo, on top of the general README on how to set up your setup. All right, so we have some explanations here. We don't need them right now because we've already discussed that. In this basic example, we are not implementing any actual logic. So everything that happens, the origin chain contract, it gets some ether from you and sends it back, because that's what it does. We will take a look at the code later. It emits the event, then this event triggers the reactive smart contract, and then this reactive smart contract triggers the destination chain contract, which also emits the event, just for us to make sure to see that everything worked correctly. So super simple basic demo. This is not a use case. This is just a demo for us to understand how to deploy a reactive smart contract. Some good explanations here. And then you will need to set up this stuff before running it, as we've discussed. And then we have all the explanations here. So let's go to Visual Studio and run all this stuff, right? Okay, so this is the README that we saw in the browser, and these are the instructions that we need to run. So the first one will be to run to deploy the origin smart contract. Then we will deploy the destination smart contract, which will be receiving callbacks, so it also called callback smart contract. And then we'll deploy a reactive smart contract, and then we'll trigger the event on an origin smart contract, which will trigger the reactive smart contract, which will trigger the callback smart contract. So let's go through these smart contracts to see what they all do. Yeah, starting with this one. So as you can see, it's extremely simple. All it does, it receives ether from a pair, right? Emits this received event with the address of the pair, address of the sender, and the value of the transfer. And then it transfers funds back, so you're not losing any funds, almost except for the gas when playing around with this smart contract on Sepolia. This is on Sepolia. This one, the callback smart contract, it's also on Sepolia. It just has one function, callback function, right? And the reactive smart contract calls this function, and this function just emits the event that we will be taking a look at on Etherscan for Sepolia. And then let's discuss the reactive smart contract. It's a bit more complicated. So let's discuss the actual React function first of all. So yep, let's scroll down. Yeah, so basically we have a constructor, which obviously runs when the smart contract is deployed. It just sets up all the things for the monitoring. So we have the contract here, which is the address of the origin smart contract. You will see it when we run the scripts. And we have a topic 0, which is a topic 0 for this event that we saw here, received event, right? Because this is the contract and this is the event that we will be monitoring. And also it has a Sepolia chain ID because we're working on Sepolia. And the rest of the arguments are ignored in that case. Yeah, also we have VM true here, because for reactive smart contracts, there are always two instances of a smart contract deployed, one on a reactive network and one on a React VM. And this is the most complicated part of all this stuff. We won't be going in detail through it today. I will just refer you to the docs. Let me show you where it's done, right? I believe it's here. Yeah, lesson 2. You can read about this thing here. It will sound pretty complicated by voice, but with code examples, it will be pretty simple. So the basic thing is that we are executing all the smart contract logic that we're interested in on the React VM instance of a reactive smart contract, and the Reactive Network instance, it manages the subscriptions and unsubscriptions to the events. So yeah, I refer you to this article, and I'll skip this part for now. And this is the thing that we're interested in. This is the React function. And this function is executed when the reactive network and the reactive smart contracts, the reactive smart contract sees the event to which it is subscribed. In our case, it's the received event from the contract on Sepolia, right? So whenever this received event happens, this React function is executed within a reactive smart contract. Let's see what it does. First of all, it emits the event on reactive network, just logs all the stuff that is happening. Also, it counts the stuff with this counter, and then it checks the condition that the transfer is bigger than 0, 1 ETH, and only in this case, it calls the callback smart contract. So here it forms the payload for the callback. So in our case, it tells that we are gonna be calling the callback function of the destination smart contract, and then it emits the callback event, which is a special event in Reactive Network, not just any event. This is a keyword, right? And we specify the chain ID, which is Sepolia, the callback contract address, the gas limit, and the payload, which is the name of the function in that case. So yeah, whenever we send more than 0.1 Ether to the origin smart contract, the reactive smart contract triggers the destination smart contract. And yeah, and this is about subscriptions and unsubscriptions. This is pretty basic. We don't need it right now for the purposes of demonstration. Now, let us go to the best part, which is deploying some smart contracts and running some transactions. Basically, we have all the stuff here so that you can just copy paste it and run it. You don't need to modify anything except for your environment variables, because all this stuff, the Sepolia RPC, Sepolia private key, origin address, and so on, it comes from our environment variables, right? So yeah, let's start with deploying our smart contract on Sepolia. Okay, it will take some time, so I will need to talk about something. So while it's happening, let me go to the to this page here. Okay, so we've deployed this origin smart contract. So we will need to put this address to our environment variables, because we're going to be telling the reactive smart contract to monitor this address through our environment variables. So I'm on Windows. It's done a bit differently on Linux, but I believe you know how to do that. So on Windows, it's done like that. We have this origin smart contract here. Okay. Yeah, I believe we might have a question in our chat, right? Oh, we have a question in Telegram. Thank you, Dave. So let's show this question. Question from Telegram. Can you give us any rough idea of how fast an RSC is able to react to a non-chain event? Yes, so a rough idea is it's going to be reacting to a non-chain event fast enough for it to execute the post action on the same chain within one block. So in order for us to be useful for some of the use cases, such as trading use cases, for instance, we need to be fast enough so that, let's say you have Ethereum, right? There is a block in which the event happens. This event happens, then Reactive Network sees it, processes it, and then it reacts, so signs the transaction and executes it in the next Ethereum block. So that's a rough explanation. With testnets, with our testnet, I don't know the numbers. With our mainnet, this is going to be the aim. And since we are going to be working not only with Ethereum, but also with Polygon, Optimism, and other chains, it's going to be pretty fast. So yeah, thank you for the question. And thank you, Dave, for sharing it with us. Okay, and I can now go back here. Yeah, let me make sure that I've copy-pasted it correctly. So this was deployed to here, and I've just put it here an origin. It ends with two A's, right? Right. So we have it here in environment variables. And also we want to take a look at it here on Cipole Etherscan, right? Right. Yeah, we have this contract here that we've deployed 2 minutes ago. That's exactly what we was going to see. Now, the next thing for us is to deploy the destination smart contract. We need to deploy it before the reactive smart contract. So when we deploy the reactive SC, we will be able to provide it with the address of the destination smart contract as well. So yeah, in our case, we're deploying it on Cipolia. It might be on other chain as well, and or on the same chain as in this particular example, right? So let's take this number here, this address here, and put it to our environment variables here. It ends with 54, right? Okay, okay. Yeah, and now I will need to close and open my terminal, which is in my Visual Studio, so that the changes that I've done to environment variables will be seen by this terminal. It won't be seen by this terminal. The terminal will be reopened. If you're using some other terminal, not from the Visual Studio, then you need to open a new terminal. That's just how Windows work. That's not about Reactive Smart Contracts. Right? Okay. And let's go back to our directory of interest. Which is our basic demo. Yeah, and also let's make sure that we have this smart contract on the destination chain, which is the same as origin chain in our case. Yeah, we can see this contract creation right here on Cipole Etherscan, right? Okay, so now the best part, deploying the reactive smart contract. So this is the script for deploying reactive smart contract. So let's, by the way, talk about the previous scripts too. So this is the command for Foundry to deploy a smart contract. So we are providing it with RPC URL here, right, with a private key here, with the contract file here. The same for the second one, and for the reactive smart contract, it basically is the same RPC URL, private key, the smart contract itself, and then we are passing the arguments for the constructor. As I have said, it's a system contract address, which is the one to which we will be subscribing to events. You can see it on the docs page, and it's included in the preparation for the like in the README, in the root of this repository. And then there's an origin contract address that we've just put there. Then there is this topic 0 for this received event, and then there is a callback or destination address. All right, let's run this stuff. Yeah, and now let's go, while it's deploying, let's go to reactive scan, because yeah, we have a reactive scan here. It's in its first version. It doesn't have all the stuff that we wanted to have, but it has a lot of good stuff already. So as you can see here, we already done this transaction. We can take a look at it. Some data here. It will be more detailed in the future. And here you can see the two React VMs that are currently working. One of them is mine. I don't know which one, but we'll see it pretty soon. So now we have deployed this reactive smart contract. And now let's actually use this whole setup by triggering the initial, the origin smart contract. So what we're doing here is we just sending some Ether to our origin smart contract from my account from which I deployed all the smart contracts above. Okay, so we're sending some Ether. Yeah, as you can see, it only interacts with the origin contract. It takes time for the transaction to be mined. That's on Sepolia, but it will be there soon. Yeah, here we go. So let's go to this contract here. Yeah, as you can see, the transfer happened. 0.11 Ether was transferred to this contract. So we can take a look at the logs of this transaction, right? Let's take a look at the logs. Yeah, as you can see, this is the received event. This is the origin, and this is the sender of the transaction, which is the same as my deployer address here. Let me show you. Yeah, this one, 7E0, 7E0, right? And this is the value of the transfer, which is 0.11 Ether. Yeah, and now let's go to reactive scan here, right? So you can see some transactions here already. So this is my React VM. These are the latest transactions. Some of them are contract deployments. Some of them are the actual reactions. So let's see what we have here. Yeah, basically it's not decoded yet, but all the logs are there, as you can see. So you can have them all in raw format if you need some debugging. And now let's go to the destination smart contract and refresh the page to make sure that our callback is triggered, which is true. So you can see this transaction here. You can see logs here. Yeah, and you can see this event here, and also the same address that sent these funds. And that's it. That shows us that reactive smart contracts work. That shows us how to deploy a reactive smart contract. And also it shows us that it's pretty easy, because if you've ever deployed any smart contract, deploying a reactive smart contract is basically the same workflow. You just need to understand what it does, and that's it. And the reactive smart contract itself is written in simple Solidity. So explaining what it does and how to write one also doesn't take a lot of effort. Yeah, so with this being said, let me go back to our translation, and let us see what we have left for today. And what we have left for today is an in-depth look at our new Reactive Bounty program. Yeah, so we're not talking about reactive smart contracts just for fun, right? We're talking to create some of them, so you might be interested in using them, and that's what you might be watching this workshop for. But also you might be participating in our bounty program. So let me run through some details of this thing right here. Okay, for that purpose, I will need to go to this repo again. Okay, so we've already discussed the use cases that we're interested in for building. So let's discuss the bounty program in general and judging criteria in particular. So the first stage of the bounty program was our community members submitting some of the ideas, and thank you guys very much for that, because some of these ideas were used, and many of them basically were used in our bounties and in our use cases. So whenever we have a next bounty program, You will be able also to submit ideas. And also we're going to be running a hackathon soon, which is basically a bounty program, but bigger with more complicated tasks and bigger prizes. And there we will have a no coding track, probably, where you can describe your ideas in detail, like with business specification and stuff, and win hackathon on that, right? And here, people who submitted the ideas that will win the bounties, they will also be rewarded, I believe. So for bounties, we have prizes of 400 to 600 USDT worth of PARSIQ tokens for Reactive Smart Contract bounties, and also Reactive dApp Bounty, which is just one of them, but it's bigger with 1200 USDT worth of PARSIQ, right? So for Reactive Smart Contract Bounty, you just need to develop a Reactive Smart Contract. For Reactive dApp, you will also need to develop a front end, basically just a front end. You can use someone else's Reactive Smart Contract. Okay. Yeah, so a successful Reactive Smart Contract bounty must implement all those things, which are basically super simple requirements just for all this stuff to make sense. I won't go through all this stuff. You just need a GitHub repo. You need the code that runs. You need to run it on the Reactive Network and Sepolia, and you need to provide the transactions. And the only thing that is not obvious here, it's this one. If the application implements cross-chain functionality, it must be emulated by working with two separate origin and destination smart contracts on Sepolia testnet that only communicate through the Reactive Smart Contract. So since for the testnet, we only support one chain, which is Sepolia, Ethereum Sepolia test network, but we also want to explore cross-chain use cases, we're using this workaround for you to be able to play around with cross-chain functionality as well, because it doesn't make a lot of difference from the development standpoint whether the origin and destination smart contracts are the same or on different chains. You just deploy two smart contracts on Sepolia. You just pretend that they don't see each other by them not calling each other's functions, right? And then you run a Reactive Smart Contract that listens to the events on one of them and does the post actions on the other. So this is pretty straightforward. This is just for you to see that cross functionality is also available for bounties, right? Yeah, and also like I hope that we will see more than one application for one bounty, or if no, then the only bounty that follows all the requirements will win the bounty. The only application that follows all the requirements will win the bounty. But if we have several of them for one type of bounty, then we will score them internally, and the best one will win. So we will score them basically on the detailed explanation of the problem, the clear and concise documentation. Basically, you don't need a lot of documentation here because these use cases are pretty simple. So just make sure that it explains what you've done, right? And like if you want to do more, it's always great because it will help us to explore the functionality and the possibilities of Reactive Smart Contracts more, which we are here for with this bounty program, basically. So the application that has more functionality and the deeper research wins. And yeah, make sure to describe the workflow that your Reactive Smart Contract is following. Yeah, and then there's also a Reactive dApp application. So you can build an actual dApp on top of your Reactive Smart Contract. Here we call a dApp where when you have a front end for it. So this is basically the same setup as before. You have an origin chain smart contract. By the way, you're not obliged to deploy your own origin smart contract. You can use some of the existing ones on the Sepolia Network. I believe they have a lot of Uniswap instances there, some Oracle, some other stuff. So you can just use data from it, and the destination smart contract you need to deploy yourself probably. Yeah, and if you have all of that, but also you build a front end on top of that, then you're eligible for the Reactive Bounty as well. These are just simple criteria for us to make sure that it actually works, because it's simple to see your transactions on cPoly and on Reactive Network, but it's harder to see your interface without your video. So the cover letter should include a video of the participant running the intended workflow in the dApp. No need for face or even voice here, just the screencast with your front end working with your dApp, right? And yeah, some of the judging criteria here, we've been over that stuff, I believe, with the addition that one participant or team authenticated by an email, a GitHub, and an Ethereum address. Yeah, I will probably need to add GitHub here, but yeah, that doesn't matter that much. Is only eligible for 2 Reactive Smart Contract bounties. And if you build this one bounty, it doesn't influence the Reactive Smart Contract bounty. So basically, maximum you can win is 3 bounties, 2 Reactive Smart Contract bounties and Reactive dApp bounty on top of that. And also, if you're only working with front end, but you're not interested in developing smart contracts or Reactive Smart Contracts, you can use the existing Reactive Smart Contracts, which are probably the ones deployed by the other participants of the hackathon. So you can, let's say, form a team with them, or just talk to them and ask to use their smart contract and Reactive Smart Contract, and you can build a front end on top of that. So to win this 1200, you don't need smart contracts. You need the front end on top of some smart contracts, and it doesn't matter whether they're yours or not, if that makes sense. Yeah, and since this is a bounty program, this is a smaller version of hackathon, we will be just judging that internally and subjectively, but we will try to be as fair as possible. And for hackathon with bigger prizes, we'll have a more complicated process. We'll probably invite some external members for it to be more transparent, and we will have more strict criteria and more detailed criteria, obviously. So yeah, here it's just for you to play around with this stuff. I believe there will be bounties where only one application will be. So if your application actually works, then you basically get in the bounty. And if you've provided the code and the transactions, then you basically get in the bounty. And yeah, feel free to play around with it. Feel free to deploy something simple. Feel free to make it more complicated. We will be happy to get any type of feedback and any type of ideas. Yeah, and also, as I haven't said, actually, we have a Telegram developer community where we make sure to answer all the questions timely. So you can ask any questions about the bounty program, about Reactive Smart Contracts in general, about any stuff. You can talk to other community members there, or you can talk to me directly. And we will be answering all the questions and basically even helping you with all those bounties. Just make sure to ask questions, right? And if you see that something is missing, for instance, some explanations are not clear for you, or you see that you're missing something for you to deploy or implement your use case, also please make sure to reach out to us in our Telegram developer community, because that's the main thing we are doing. These are the 2 main things we are doing the this bounty program for. So first is to get your feedback, to make our tech and our docs better, to make it so that it's easy to build using it. So whatever feedback you have, it's super valuable. And the second thing is to also get do a crowd brainstorming, so to say, to get ideas from you on how to implement this, or how to implement that, or what to implement. So all types of questions and feedback, everything is welcome. Yep, and it's exactly 1 hour for our workshop. It's not that we had a time limit, but I'm basically out of words for today. And yeah, thank you very much for your attention, guys. It's been a pleasure to run the first workshop for you. We are not over. We are going to the questions if you have any. Okay, so let me go through the messages. Wish there was a bounty just for showing up. Well, as a matter of fact, we might have such a bounty for our hackathon, not just for showing up, but without coding, as I have said. So you will need to do some explanation of your idea, a deep, good explanation, but you won't need to code to win this one. And for showing up, I'm just saying thank you. I'm really glad that you guys are here. Okay. Hi, Vanya. Thank you. Will there be a recording of this stream? Yep. Just after we end the stream, it will be posted on our YouTube, so you can work. You can see it again, or you can send it to someone who hasn't seen it, and you're welcome to do so. And also, you will be able to watch it on bigger speed, right? Okay. And yep. That's it with the questions. So I'll just sit here for 1 more minute, say some outro words, make sure that we don't have any more questions for today, and wrap it up. So yeah, thank you guys for being here. It's been a pleasure to run this workshop for you. This is the first one for the Reactive Network. So we've done workshops before for our previous product, a data solution, but this is the first one for the Reactive Network. And yeah, make sure to check all the links that you might be interested in the description below. You might take a look at our docs. You might join our developer community if you're a developer. And feel free to join our bounty program. And please also feel free to share our bounty program with your developer friends, and tell them that it's pretty easy for them to win some money just by deploying some Solidity smart contracts. I believe they might be really interested in that. Yep, and since we don't have any more questions, thank you again, guys. Have a great rest of your day, and take care. Bye.